Alright guys, so in this video we are going to talk about sign charts for rational functions. But before we start talking about sign charts for rational functions, we want to ask ourselves a question. The question is, are real zeros or x-intercepts the only way for a function to change signs, right? For a function to go from above the x-axis to below the x-axis, or from below the x-axis to above the x-axis? And the answer to this is, of course, no. We can also change signs at an x value that gives us a vertical asymptote. So right here, if we've got y equals 1 over x minus 2, right, we would say that this function has a vertical asymptote at the x value of 2. And if we look at the graph of this function, right, we would basically see at -2 that vertical asymptote, and our graph would start out below the x-axis at the horizontal asymptote, and then as it approaches 2, it's going to go down to negative infinity, and then on the other side of 2, it's going to come from positive infinity, and then go back to that horizontal asymptote of 0 that this function would have. So right here, we're seeing our function change signs at the x value of 2, where we have that vertical asymptote. Now, in general, one of the things that we can say here is that if the 0 in the denominator that's giving us a vertical asymptote has a multiplicity that is odd, our function is going to change signs at that vertical asymptote. But if we have a 0 in the denominator giving us a vertical asymptote, and that 0 has a multiplicity that is even, we will not be changing signs. So right here, we're going to take a look at this example, group this stuff together, shrink that down. If we have the function, this up here, if we have the function y equals 1 over x minus 2 squared now, we're going to get a vertical asymptote at the x value of 2 again, right? But right here, if we think about the graph of this function, we can see that the graph of this function is never going to have y values that are negative, because whatever we plug into the denominator is always going to be squared, so we're always going to be dividing 1 by positive numbers. So right here, we're going to start out above the x-axis, right? And as we approach that vertical asymptote of 2, we're going to go up to positive infinity, and then on the other side of that vertical asymptote, we're going to come from positive infinity and go back down to the horizontal asymptote of 0, and be positive just above that horizontal asymptote of 0. So right here, the 0 in the denominator has a multiplicity of 2 in this case, and what we're seeing is that vertical asymptote does not indicate an x value where our function is going to change signs, like the x value of 2 did for our first example, where the multiplicity was odd, or 1. So in general right here, when we're going through and evaluating these sign charts for rational functions, we're going to find the zeros from the numerator, which are going to give us x-intercepts, and we're going to find the zeros from the denominator, which are going to be vertical asymptotes, and we are going to mark those vertical asymptotes and those x-intercepts off on the sign chart, and we are going to then go ahead and evaluate the sign chart in the exact same way that we did before. So in general, looking at the evaluation of a sign chart for our f of x right here, I'm going to go ahead and get the zeros, and right here we're talking about the x-intercepts, and these are going to come from zeros of the numerator. And then the x values where I'm undefined are going to be the vertical asymptotes, or the zeros of the denominator. So right here, looking at our first example, we've already got our numerator and denominator factored, so right here we can say the zeros, or the x values that will give us x-intercepts, the zeros of the numerator. We're going to get 5. We basically just have the x value of 5, and it has a multiplicity of 1, right? And for the zeros of the denominator, where we'll have vertical asymptotes, we have the x value of -1, and it has a multiplicity of 1, and we've got the x value of 3, which has a multiplicity of 2. So right here, what we're going to do is go ahead and just draw our sign chart. Now, it didn't give us a little line right here, but it's not too tough to draw a horizontal line. that can be our model of the x-axis. And right here we're going to mark off the zeros from the numerator and the zeros from the denominator, right? The x-intercepts and the vertical asymptotes. So right here we have -1, we have 3, and we have 5 as the places where our function could change signs. And again, just like before, what I want to do is take an x value from one of my 3 intervals and plug it back into the function and determine if that x value is going to make my function positive or negative on that interval. So right here, the easy x value to choose is 0. So we will go up and plug in the x value of 0. And right here, when we plug in x equals 0, we have that linear factor in the numerator, and we've got a linear factor in the denominator that has a power of 1, and we've got a linear factor in the denominator that has a power of 2, or that is being squared. Now right here, when I plug in 0, I can see that that linear factor in the numerator is going to be negative. The first linear factor in the denominator, x plus 1, is going to be positive, and the second linear factor in the denominator would be negative if we plugged in 0, but since we're squaring it, we know it's always going to be positive. So I'm taking a negative and dividing it by the multiplication of 2 positives, and that is going to give me a negative for my function value when I plug in the x value of 0. So that means that I'm going to be negative on this entire interval. Now we're going to go across our x values that give us intercepts and vertical asymptotes, and we're going to look at the multiplicity to determine whether we change signs or not. So right here, when I cross over the x value of 3, which would be where I have a vertical asymptote, I can see that I have a multiplicity of 2, so I'm not going to change signs, I'm going to stay negative. When I cross over the x value of 5, where I would have an x-intercept, I can see I've got a multiplicity of 1, so I am going to change signs there, right? And going back, and when I cross over the x value of -1 from this interval between -1 and 3, I can see that -1 has a multiplicity of 1, so I am going to change signs there as well. And now right here what we can say is that this rational function is going to be positive on the interval from -infinity to -1, union with the interval from 5 to positive infinity. And this function is going to be negative on the interval from -1 to 3, union with the interval from 3 to 5. Keep in mind here that the function doesn't exist at the x value of 3 or the x value of -1, because those are x values that are going to make our function undefined where we have zeros in the denominator. So actually right here, these two x values are not on the domain of the function, right? So we couldn't list them in either of our positive or our negative intervals. And in general right here, we wouldn't list 5 either because it's an x value that makes our function 0, right? Now right here, we of course have a graph of the function. I'm going to erase our work so we can just take a look at that graph. And right here, going down and looking at this graph, basically right here we can see the graph telling us what we determined. It's a little tough to see right here, but we are in fact crossing the x-axis at 5, right? So right here we start out positive above the x-axis, right? Then at the x value of -1, we have that vertical asymptote, which causes us to go up to positive infinity. And then on the other side of -1, we're negative in between -1 and 2, and then at -1 and 3, and then at the x value of 3 we go down into our second vertical asymptote, but since that x value giving us 0 in the denominator has a multiplicity of 2, we don't change signs, so we're coming up from -infinity there. And then right here we're crossing at the x value of 5, and you can just barely see that we're crossing there, right? And part of the reason for that is that if we looked at this guy, we could say that he has a horizontal asymptote of y equals 0, right? What we're going to do is skip this guy right here, this polynomial. It's not a polynomial, it's a rational inequality. And we'll look at a problem like this in class so that we've got an example to check out. But what I want to do right here is give you guys a chance to try some of this stuff out with a sign chart. If we look at the next page here, I'm going to give you guys a little bit of a hint. Right here, we've got this square root in the denominator. And so right off the bat, we can say that the x values that are less than -5 are immediately going to make us undefined, right? And then we can also say that we can't equal -5 because that would give us a 0 in the denominator. Now, right here, what we're saying then is that we are going to start this sign chart after -5. So our function doesn't exist behind -5. And right here we would say that we are undefined at x equals -5 because that's a 0 of the denominator. But then we're also undefined when x is less than -5. So right here we're going to pause the video and give you guys a shot at these two. The first one right here, we're sort of giving ourselves a little push because we know these two things from that square root in the denominator. If we look down at our second example, we're going to have to do some factoring before we can evaluate that rational function. But it's a lot like the one we saw before. So when we pause the video here and give these guys a shot. All right, guys, so looking at this first one, we can get the 0 of the numerator as x equals 2. That has a multiplicity of 1. And the zeros of the denominator are going to be a -3 and 5. Really, we don't have to worry about crossing over 5 because we're -5, rather. Really, we don't have to worry about crossing over -5 because we're not going to exist behind -5 because we'd have imaginary numbers from that square root in the denominator. So the two zeros we're really going to have to think about are the 0 in the numerator of 2 and the 0 in the denominator, giving us the vertical asymptote of -3 that also has a multiplicity of 1. So right here we mark off these points on our sign chart. We've got -5, we've got -3, and we've got 2. And right here we want to choose an x value that is going to be easy to plug into our function and evaluate for a positive or a negative as far as our function values go. So of course 0 is probably going to be the easiest one for us to choose. So we take 0, which is on the interval from -3 to 2. We plug it in and we can see that we're negative for x minus 2 in the numerator. We're going to be positive for x plus 3 in the denominator and positive for the factor that's going to come from the square root, that x plus 5 in the denominator. So right here we've got a negative divided by the multiplication of two positives, which is going to make our function value negative on the interval from -3 to 2. So right here what we want to do is think about crossing over the 0 in the numerator of 2, which is going to be an x-intercept, and the 0 in the denominator of -3, which is going to be a vertical asymptote. So right here when we cross over 2, we can say that the multiplicity of 2 is 1, so we're going to change signs and we're going to be positive from 2 to positive infinity. And when we cross over -3, the multiplicity of that 0 in the denominator is also odd, so we're going to change signs again and we're going to be positive from 5 to -3. So right here we would say our positive intervals are from -5 to -3 and 2 to positive infinity, and we are negative on the interval from -3 to 2. Now we're going to worry about graphing next class. We're going to talk about graphing on Friday. But for right now, we want to basically just be able to identify where our rational functions are positive and negative. So let's take a look at this second problem. Right here, we can factor the numerator into x plus 4 times x minus 3, and we can factor our denominator into x minus 2 times x minus 2, or x minus 2 squared. So right here, the zeros from the numerator are both going to have a multiplicity of 1, and the 0 from the denominator, giving us a vertical asymptote, is going to have a multiplicity of 2. So right here, we mark these guys off on our sign chart, the zeros, and of course we're going to look for the easiest x value to plug in. The easiest x value is still going to be 0, so that's on the interval from -4 to 2. So right here, we will take that 0 and plug it into the factored form of our rational function. When we plug 0 into x plus 4, we get a positive number. When we plug 0 into x minus 3, we get a negative number. And when we plug 0 into x minus 2 squared, we would initially get a negative, but because we're squaring, that negative becomes a positive. So in the end, we can say that our function is going to be multiplying a positive and a negative in the numerator and dividing by a positive, which will give us a negative function value. So our function is going to be negative on the interval from -4 to 2, right? Now crossing over that 0 of -4, we are going to be positive because we have an odd multiplicity, a multiplicity of 1. When we cross over the 0 of 2 from the denominator, that vertical asymptote, we have multiplicity that's even, so we won't change signs. We'll stay negative. And when we cross over the 0 of 3, we've got an odd multiplicity again from the numerator, and we will change signs. So right here we can say that our function is going to be positive on the intervals from -infinity to -4, and from 3 to positive infinity, and our function is going to be negative on the intervals from -4 to 2, and from 2 to 3. And again, we'll worry about graphing on Friday. We'll talk about that more then. Okay, guys, so right here, we are going to stop the video and see you guys Friday.